we're here with Nathan from Simplivity, who's actually going to give us a run through for the actual administration system and what performance benefits we can expect using their new hardware accelerator technology versus a traditional server/network system such as those with Linux or Windows without any hardware acceleration.
So here we have a virtual desktop, and I'm just going to log into our GUI, which is in fact the standard vCenter vSphere client.
So you guys have a plugin that goes onto VMware, and that exposes all your different controls on top of that.
That's correct. So we integrate absolutely all of our functions in through this GUI, and this inserts the Simplivity tab here, which gives us a view into the federation.
So this is obviously your test case. So what compressions are we looking at here? Because obviously, as Scott was saying earlier, what you guys excel at is in a very high ratio de-duplication. So what ratios are we looking at here?
That's right. On a physical capacity basis, what we see here is VM data, so virtual machine data is 15 terabytes.
So those are the actual sizes of the virtual disk images?
Correct.
Okay.
Of that, we're taking some local backups, and so there are logical full backups of those VMs.
So what is the difference between, say, a logical backup, an image-based backup, and block level? So
well,
what is a logical? Just loose files in a folder?
Yes, so full logical backup is an image that has no grandfather, father, son based history. So there's no linkage between each of them. They're in their own
So, for
right.
example, if you do, say, an incremental backup on Windows Server, all those backups will be linked into each other because
Correct.
they're time-based.
You'd have to restore the previous full and then apply each incremental.
Yeah, but obviously when you click the most recent one, it will work out which ones, and it will merge them all together, and it will push that.
Yeah, there are some smarts in the backup application that do that, that's right. But we remove that complexity completely because of our de-duplication technology.
So we've got logical files. So how does your system track the dates and the sizes and the checksums and...
Yeah, well,
that's
from a backup perspective,
that's built
there's
into
a
your
catalog.
stuff.
The catalog, which I'll get to in a minute. I think just this is focused on that. The VM data is 15 terabytes. The logical backups are 247 terabytes. And we have some remote backups from a remote system that are being sent into this system.
So you are pushing those from one
data center to another data center.
Okay.
That totals 265 terabytes logical in the system. But when we look at our de-duplication and compression of 65 to 1, we're reducing that to a physical usage of just over 4 terabytes.
Just from hypothetical, how much can you shrink, say, just the base Windows install, for example? Yeah, how much would it shrink?
That's a great question. Now, I know for a fact, let's just open up a VM.
Just for simplicity, so let's say Windows Server in 2008 or 12, just for discussion.
Which is about a 12 gig image
from
memory.
12 to 20, something like that.
The first backup is around 4 gig.
Wow.
That's for the very first one of a first VM. Any subsequent one is de-duping against that.
The reason I mentioned Windows, and it's a great example actually, is one of how Windows works is a lot of side-by-side files and a lot of redundant libraries and a lot of redundant stuff, and so that's something you guys could take care of.
Approximately the initial ones are 3 to 1.
3 to 1.
Yeah.
Okay.
3 to 1 saving. So what I have here in my lab is I have 2 data centers. Let me just shrink this one here. So you might not be able to see it too, but we have a New York data center and Shanghai data center.
So in this demo, how are these connected? These connected via just the commercial WAN links, whatever?
They're not actually they're in the same physical data center. We're just logically...
Just a simulation. This is a simulation.
Correct. It's a demo. So.
Okay, but doesn't that affect our time because obviously when we transfer something over the WAN in different bandwidth layers...
Of course, but we don't have an office in Shanghai that we can physically go and install.
Fair enough. You're doing the best.
I'm doing a demo at the moment with a partner here in Sydney, and they have one box in Sydney and one in Canberra, and we're going through those tests at the moment around bandwidth limitations and capabilities. There is, in that case, we basically load up the same images at both sides. So for the initial transfer, it does a check between both sites, and it doesn't actually have to transfer all of that data.
So it just works out like, okay, I have, say, 60 files here and 60 files there, I need to change 4 of these files and so on.
It's done at the block level, though. Okay. It's done at 4 to 8K blocks, very granular level of de-duplication. So basically, yes, the metadata can check what's at the source and compare it to what's at the destination and only send the changes.
So you're talking about 4K blocks, so is any of when the Accelerator card is doing all this work, does the Accelerator card actually store anything in the card permanently, or is just the process?
There's nothing there stored permanently.
Okay.
Basically, the card has multiple purposes.
Yep.
RAM.
Yep.
Some NVRAM.
Scott showed me the card.
You've seen it. That is used as our initial entry point to ingest data for both and to reads and writes.
Yep.
Now, as data is ingested, it's obviously processed by the FPGA, the algorithms, etc. But to persist data to our hard drive here, it's a full stripe write onto those physical hard drives. Reads, on the other hand, and that's only for the unique written blocks that need to be written. So we're deduping a lot of those IOs at the card layer in DRAM.
I think the only thing we didn't get when Scott originally demoed the card to us a few months ago at a different media briefing was the card has its own LAN connector. So it has its own RJ45 connector, so I'm not sure how that integrates.
That's just a service port.
Okay, yeah. So administrator doesn't need to hook that to the management system or anything.
Not at all.
It's all
integrated
in the software.
Correct. I can show you. So basically, if we look down here, we can see we've got two physical Omnicubes running here in an HA pair. So every write is actually dual written to each system for true HA. And on there we have an Omnicube virtual controller, which runs, we have our own OVA, it gets deployed, it takes up a certain amount of RAM, CPU, very small amount.
And all this is within the VMware ecosystem?
Yeah, that's right. Okay. And basically all of the reads and writes are transitioned through a virtual controller.
Okay.
So that's our link to...
So say you have five of the redundant machines that will copy.
If we had 5 Omnicubes in here, you'd see 5 of these virtual controllers. So that's the software link to the hardware card. But we don't expose that. We make things very simple. So
would you say that's sort of your hypervisor?
Well, we actually sit below the hypervisor. We have a presentation layer which presents up to ESXi. In this case. And we have a data management layer which looks after all the bits and bytes and where they need to be in the federation. Now, I spoke about creating a data store. It's literally as simple as a right click and then a left click Simplivity data store. We can choose the data center we want. Now in this case, I could got New York or Shanghai. So if I'm an admin sitting in New York, I can remotely deploy a new data store. We'll just name this one demo 1. We need to create a default backup policy for our data store. So any VM that's created on that data store has some level of protection. So we'll just pick bronze daily. And we can create a logical size of anything we actually like. You basically over provisioning. I'll just do a 50 terabyte.
So just to be clear to my viewers, the operation we're doing right now, we are backing up a VM.
No, we're creating a new data store that VMs can then reside on.
Okay, sure.
So it's just basically adding usable capacity.
So there's a virtual data store on one of the systems.
But it's actually, ESXi sees it as a physical data store.
Okay.
So we just created we're creating a 50 terabyte data store to be used within this environment. The store is what's presented up for ESXi to use as its storage pool within the environment. So I already have some existing. If we go to the Simplivity tab on a VM, you'll see. So we have in the federation, data center is New York. This VM resides on New York 01 data store, which is currently being used via that host, and this is the name of the VM. So this VM itself is actually nearly half a terabyte in size, so 482 gigabytes. It has 1 virtual hard drive, 2 CPU,
so
12 gig of RAM.
500 gig VM we're working with.
That's right. So to create a backup of this, we can set a policy, and this policy is 10-minute refresh. Now, I'm going to say, well, that's too much. I don't need to do that anymore. I can go in and change the backup policy for that VM to be bronze, which is once a day.
Okay.
And I just change the backup policy.
Absolutely.
So then every day, and I've given that policy a backup window that it needs to run between, I think it's 10 p.m. through to 4 a.m. So any time within that window, it'll be an automated backup that will occur.
Right.
Any failures just get sent as an alarm within vSphere. And if you've got your alarming mechanism set up to email you or let you know a notification or open a case, etc. But within here, you can see very, very quickly if there's a failure, because the status goes from being protected to being failed, or a percentage if it's in progress. So I'll just show you very easy to create an ad hoc backup, because we're not going to wait till the next one runs. You right click and you can see how integrated we are. You still have all the same vSphere options available.
All these backups are logical. You guys don't support like full images.
It is to any administrator, it is a full image backup.
Yeah. Because some users, they might want to do sector by sector, and that's obviously a bit of an old way of doing things these days, especially with your technology and block level.
Correct.
Yeah.
I mean, when you get to a certain point, it becomes unfeasible, unmanageable.
And that's why we're talking with you guys today to look at your Accelerator.
Exactly right. And there are other technologies that are around to extract the VM data and de-duplicate it, but those involve some kind of VM load on the CPU and RAM to actually process the backup, to read the data off of disk, and then to catalog it and move it elsewhere into another discrete system. We remove that whole complexity, as you heard Scott talk about, by having those different discrete systems and silos of different data. We're removing that complexity. Each one of those products has a separate GUI, maybe 2 or 3. They have a separate command line. That complexity is completely removed by us inserting ourselves directly into this management GUI. So all I need to do is do a Simplivity backup virtual machine from a right click on that VM. I can select a name for that. I'll just call this test 01. And we can choose where we want to back that VM up to. We can do it locally in New York, or we can send one remote. So say, for example, this wasn't Shanghai, it was Melbourne. So we had Sydney, Melbourne. We could send a backup to Melbourne.
And now we're going to be able to see how small.
Correct. So I'm going to send this backup.
So we're sending 500 gig to a remote data replication.
To a remote site.
Yep. And this will tell us how much data we've saved, because it's going through the contents of the VM, it's scanning what's identical, and it will only send whatever the unique data is over the WAN link.
Absolutely correct. So I've issued that up. Just by the way, the create data store there took, 1 second.
So
50 terabytes to create a 50 terabyte data store took 1 second.
Does that leverage yours, or that's just a VMware thing?
No, that's our technology, our data management presentation layer saying, here's 50 terabytes for you to use and consume however you want. So that backup has succeeded. I'll just refresh this one. Bring that up. Now that took backup in from Sydney to Shanghai, 46 to so we 50 to 11. So I'm not very good at maths here, am I? 50. So 15 seconds.
Okay, and how big was the transfer?
The transfer was 507K. So half a terabyte, fully protected machine sent half a meg.
Okay, so what was in that VM in the first place to bring it down to that much?
Well, it's only having to send the changed blocks because it already has, the remote site already has the blocks to make up that VM. So it only had to send anything that was new since the last point in time that it had actually sent data to it. And those blocks could be from a Linux machine, it could be from another Windows machine, it could be from anything. A block is a block. It doesn't have a reference to the VM itself, if you know what I mean, because we're abstracting that from a logical perspective. So now
the original VM was that had an operating system and apps on it, or?
Yeah, I can show you in here actually what it has.
So it was 500 meg image, and how much data was on it though?
500 gig.
Yeah,
there's 480 gig on that VM.
Okay,
including operating system, and there's actually an internal set of database files that I created. A mixture of de-dupable, non-dupable, compressible, and compressible. And within here, I have created a DB set of files, so DBF files, and I back them up to copy them. So some of these are compressible and some of them are not. They're unique. So that's how we managed to build up half a terabyte. So imagine that's a half a terabyte SQL server.
Yeah, I'm fine with the full image. So I'm just trying to see how we got it down so small. So for a couple of gigs I could understand, as we talked about earlier, 3-to-1 for a base Windows blank install. So we said, was it 3 to 4 gig? We said, I think it was.
Yeah, for the initial. But once any subsequent one gains massive efficiencies because we've got the data blocks.
We've already got those 4 gig.
Correct.
So the only thing that 500K is, we did a backup. That was the second backup.
It was actually maybe the 20th from memory. It's just been running. This demo's been being used for 2 weeks, right? So, yeah. But the point is. So that 500, as a logical backup, if I needed to rehydrate that to another system, external storage, you would need half a terabyte of capacity. So
that was 500 for the day's backup.
500K.
Yeah.
Well, I just did a manual backup.
Yeah. Yeah. So it was whatever changes in that day, and that deduplicated it down to 500K.
Yeah. That was what was unique.
So does there any way to tell us for the 500K how big that would be if it wasn't deduplicated and optimized?
There is a way. I'm not going to get into it here, but there is a way.
So that the GUI doesn't show us how much we've saved or something?
Well, you've saved the 500. You've only sent the half a megabyte.
Yeah.
That is your saving. So where I showed you here, that's telling you your savings. Basically that, minus that, you never had to send. Now, the beauty of the system is not just around backups, right? I mean, that's a really important part. And the mobility of those backups, being able to send them to remote sites for added protection and DR, and actually recover them vice versa. The added benefit is we can take a machine, let's take this O2 Windows machine here, and instead of backing it up, we can take a full logical clone, which is a full copy of that VM. And again, we'll name this one. Okay, so now we're doing a clone instead of backup, and this will basically shrink the size of the image to something unique. It's creating a complete copy of that VM as a new one called test.
Yep.
And I'm going to issue 3 of those pretty quickly, quick succession. So I've done one, and it's actually finished already because I can't type quick enough. But you can see that clone actually took, I'll bring that up in a second. Let's just issue a 3rd one. Now in a real world environment using a standard sort of best of breed technology, disk-based shared storage system, fiber channel, etc. This operation to run 3 successive clones like that could take anything from half an hour to a whole day, depending on the performance characteristics of your subsystem. And we've just issued 3 in very quick succession within a few seconds. So this is the power. So these operations are fast because you've already got an optimized, unique VMware image, and all we're going to do is just copy, for example, a few gigs over. Not even gigs. It's just a metadata operation, in essence. So then this is now we've got. Oh, that's right, because we've already got the blocks stored somewhere. So the machine is saying, okay, here's the new spot. We have got the original blocks here. We don't need to copy the blocks, because if we copy unique blocks over, then they're going to be duplicated. Correct, and we de-duplicate. Okay. Everything we ingest. I think that might be that's like a catch. Some people, if we're describing it, because when people they might think of the duplication, they might think of it as a single entity and not consider if we're cloning something. So as we just said, now any data is only once, and we don't make a copy of it. But that's the whole smarts of the system. Yep. That's the essence of the system. As we ingest unique blocks, they are deduplicated, compressed, and optimized. We didn't even need to make a copy for the life cycle of that. It's just basically a pointer to basically like an overview description of it. We're just pointing to the original data. It's now a unique VM, which I can then right-click and power on. And all it's doing now, any new data is data that is not in the original unique. It's any new data is created now, it's going to make it. And that will also be unique. Yeah, so if I go back to our data center view, and I can see now, because we took 3 clones, our VM data has gone up from it was around 14 terabytes. It's now 17 terabytes, but we're still only using the same 4.1 terabytes of physical capacity.
Because there's many clones as we make of the original data, it's not going to take more space unless we add more to those new clones.
Correct. So this is how we get our efficiency and the speed of management, which is a really key factor in rolling out new VMs or migrating VMs. The use cases are phenomenal when it comes to things like remote office, back office, sites that have maybe thin WAN connections. We make great use of the capability of our system, allow remote management and data protection at those sites, which today are costly and inefficient. So one thing that you asked, Scott, which I can show you here, is I've got a stack of servers that I don't want to get rid of yet.
That was our main concern when we were looking at the technology, because obviously, as we discussed earlier with Scott, each company, each administrator has their own preference and policies for purchasing and whose equipment they use. For example, we are used to Linux and Supermicro, for example.
Exactly. So you've got some Linux. Because we're hypervisor agnostic as a technology. But today we have only come to market with vSphere, with ESXi hypervisor, and that's purely because they're the biggest by market share.
Sure.
We are working on a release for Hyper-V and for OpenStack KVM based
OpenStack.
hypervisor. Yeah.
Okay.
That will be coming early next year. Now, that's if we stick to release dates. But say you do have an existing HP server, which I have here, and a Dell. So I'm going to click on my Dell 720. I'm going to right click on it and then go manage data stores via Simplivity. Now I created a data store earlier, 50 terabyte one.
Okay.
There it is, test. I can select that data store and click OK, and it's going to share that 50 terabyte data store with that non-Simplivity compute node.
Okay, so we have a 50 terabyte store. How does it use up all the available space on that Dell?
It's not. The Dell it's an NFS mount to the data store that resides on these Omnicubes here.
Okay, so
yeah. So we've now presented storage that has all of the dedupe, the compression, the optimization, the data mobility around where we can back up and recover. All of that great stuff that we have in our IP, but it's all being run on the customer's existing compute node.
Okay, so for example, say we have one of these accelerated servers and I want to do a backup, I can send that to that new HP and it'll send it to the data store.
VMs that are running on here can be protected, yes, that's correct.
Sorry, the VMs running on the legacy system or the new systems?
Any VMs running on that legacy server can now be protected. The data can be protected.
Okay, so not out.
Way.
So the Simplivity system can input data from legacy system, not send it to the legacy system. For example, say I want to expand the storage, I want more storage to store unique data.
The storage resides within the Omnicube Federation.
Okay.
Yeah. All we're doing here is sharing an NFS pool, or data store, as it's known in vSphere speak, to those legacy hosts for use. So you can then move your VMs onto that new NFS data store, and they gain the benefit of our data efficiencies and mobility.
So it's an expansion of the storage pool.
Correct.
So I have 50...
Well, not storage pool, of the compute capability in your environment. We're allowing the existing compute to utilize our storage functionality.
Yeah.
Basically, because most people have different aging and life cycle, refresh cycles within their environment. So most people don't need to...
And I think also some administrators, because this is obviously a bit new and unproven, they would like to maybe...
I don't think that's right. It's not unproven. We have over 3,000 of these systems deployed worldwide today.
Well, relatively compared to the age of the company. I mean...
2009 we founded. That's getting up for 6 years.
I think some administrators would like to maybe deploy maybe the minimum or maybe a baseline of your equipment and see how that goes and just leverage whatever they already have.
And that's one of the fantastic things about this technology is you can start with one single cube and you can then grow that environment and scale it in very small 2U blocks.
So as Scott was mentioning earlier, there's like a ratio for, say we have one of your boxes how many legacy boxes can we incorporate within the federation?
Yeah, we have some guidelines around that. So today it's you can have 4 physical linked to one Omnicube is the guideline.
Okay.
It used to be a 1-for-1, but with our newest release, 2:111, they upped that guideline.
So is that ratio just based on the power of the card, or?
It's based on the I/O capabilities, basically, and they're just guidelines. We don't have physical or theoretical limits in our systems. We have guidelines and best practices.
Obviously, any accelerator card has its limits, so have we reached the limit yet? No. I mean, maybe in the future we could say maybe 1 to 20 or something. Maybe
Correct.
With the better software, better drivers.
And depending on the workload of your systems would depend on how much you can, that would create the limits.
Okay, so let's just recap of what the demo we've done. First, we did a backup of a 500 gig, and how much did we save on that?
Well, we only sent 0.5 MB to the remote system. So what I haven't done yet is with this clone, which I've started and powered on here, I'm going to power it down. And I'm going to delete it. Quite a common procedure. Delete from disk. It's gone. So the person, the developer or the user, 15 minutes later said, no, it was a mistake. I need that VM back. And you can say, well, I know I backed up that VM to Shanghai. And we probably got a local backup too, but this is just for example's sake. I can right click on that data center, do view backups in that data center, and this is, logically it's a separate physical location. There's my backup. Yeah, there's the 500. So I can right click on that backup, which is just like a standard catalog in any backup.
Sure.
And I can restore that VM. I can even copy that backup. So I can copy it if I had a third or a new data center. I could move that backup image. So I'm going to restore that virtual machine.
So this catalog, this is a mix of different schedules, isn't it? So the most recent schedule we were demoing, that was a 1-day schedule. So this catalog is the combination of all different schedules you've been using for demonstration.
Correct, it's a global catalog.
Yeah.
So I'm just going to call that, again, test01, so we know that. I'm going to restore it locally in Shanghai.
And so from the backup processor we demoed earlier, so this is obviously only just backing up the unique blocks. So it's scanning and going in and only doing the unique blocks, and that's what we're restoring. It's never rehydrated.
Well, I've restored a full logical copy of that VM now.
Yep.
So it's recovered, and that took 7 seconds. It took 1 second to register the new VM. And there's my VM there.
And that backup, that was because we're going through the metadata and working out which blocks we need to reassemble.
Well, I've now re-instantiated a copy of test01, which I deleted over here. And that took 7 seconds, 1 second to register, 8 seconds in total before that VM is available for use and power on. And that time is it's unheard of in the IT industry. To be able, that ability to re-instantiate a full VM and power it on in that amount of time through a single right-click GUI. That when we talk about hyperconvergence, it actually includes one of the key things that is spoken about is the single pane, the true convergence of all of the different technologies through a single view and a user management system.
That's interesting.
So there we are, we powered on that VM.
One thing I just realized when we just booted this operating system up, so from the low level, the system is only handling and looking at unique blocks. Say Windows, for example, say something has gone wrong in Windows and Windows tries to repair it, the disk or check disk or something. So the Windows is trying to do funny things to the disk. So your system, how does that interact with your system, because your system is only handling unique data?
Yes, so in the presentation layer, that's a logical full view to Windows. So the Windows operating system would see its C drive, D drive, its NTFS partitions, as it always would. And that doesn't change whether it's physical or virtual. So if a check disk is issued, not that I don't think many people do those today,
So let's say, for example, say there was something wrong with the link, and say all your multiple ECCs, didn't pick it up. So things go wrong with Windows. Everybody knows that. And say a check disk did happen from a dirty shutdown or whatever. And how is that? How is your system like? Because your system,
a check disk is a full read.
Windows will do one thing, and your system does another. Because obviously it's not one-to-one. You're doing unique data, and Windows is seeing things virtually.
It's a great question. So a check disk is a sequential read of the entire partition, correct? So what would happen in that case is not all of those read blocks that are required for the check disk are going to be in our cache. So what happens is, as the scan begins, the blocks that need to be read get moved up from our hard disk drive tier up into an SSD read cache tier. And all of those reads, if they are not in DRAM ready to be serviced from the card, will be issued straight off of the SSD.
Okay, I see. So if some data is missing from the check disk, your system tries to find the data from the different tiers of storage you have, and it retrieves it.
From a presentation layer, it's irrelevant. The data will be available to the VM.
Yeah.
When it issues the read request for that block, for that logical block, we will service it like as any other storage vendor would. Absolutely. So
from top to bottom, there's not going to be any synchronization issues. It's all taken care of by your system.
Yes, absolutely. The same as it whether you were running. We were abstracting away our tiered storage system from a perspective of the VM and the hypervisor. It just sees the data store. It doesn't know what is behind that data store. It just looks like an NFS data store.
Okay. That makes sense.
Okay. So what I've got here is my VM, which I've restored as a clone. I've powered it up. I've made sure that it's got the data that I need and it's the right restore point. But my developer wants it back in the New York data center. So now I can right click and do a move virtual machine. So we've done a backup. We've done a clone, and we backed up that clone, and we've recovered it, and now we're going to move it back to where we want
So we're moving the VM?
Yeah.
Okay. And this is the same for 500?
This is a full 500 gig VM, correct. So I issue I'm moving it back to New York. I specify the data store I want.
And does New York say we have Shanghai in New York.
Yep.
The blocks are not replicated exactly one-to-one. Each site has unique blocks, and they're backed up locally.
Correct. Well, the way that we have it's a distributed file system, so the metadata is kept in I call it an async because it's synchronous within a data center and it's async between separate data centers. But the metadata is a shared pool. So if it's actually going to move very little data back for the move because we actually originally backed up that VM from New York. But we've moved that back, and there it is. And that move took all of 38 seconds. And we automatically do the unregister from the Shanghai Virtual Center all the way through to the New York and re-register it. And that's now ready to be powered on and used. So
that move, it took some blocks from Shanghai and some blocks from New York, or all the blocks? How does the split of the blocks work when we're moving from one to the other?
Because this VM originated from the New York data center, it probably only had to move a couple of K because I powered it on in Shanghai, so there will have been some changes, small low-level changes within, the boot log and setup.8, things like that.
Local,
and those are the only things that would need to be moved, that would have been moved.
So the move so that's probably what got transferred over. Is it
correct?
Little
just
tiny
those
changes?
Tiny changes, yes, that's right.
Because all this is basic, as you said, it's abstracted and it's virtual. We're not actually moving disk images back and forth. We just pointers or direction or here and here.
Yeah, and why no one else can do this is the power of that software, the OmniStack software stack, coupled with the hardware accelerator card.
That's quite interesting. And as we said earlier, we hope that At Nitro, we're quite, as we focus on PC hardware, we're quite enthusiastic about GPUs and hardware accelerator cards. And for a server vendor to embrace hardware acceleration, NVIDIA and ATI were the first with putting the GPU in the server, which was once unheard of. And now we're going into IO acceleration, and that's something we're quite keen to see, and we're quite keen to see your accelerator card and maybe other people copying your accelerator card, and hopefully one day these will be pervasive in servers. Maybe one day there'll just be a small chipset on the motherboard. So I think this may be a start of a revolution that might take some years to complete.
That's right, and we're us at Simplivity, we're very excited to be here at the beginning of this hyperconvergence.
Thank you very much, Nathan.
Thanks.